Hello, everyone. Good morning, good afternoon, good evening, depending on where you are. Thank you for joining us on this webinar. We are going to start in a few seconds here. My name is Sean Gores. I'm a sales engineer here. Today, I have the pleasure of having our VP of Product Marketing, Rohit Kalbak, with us. In a second, I'm going to let Rohit say hi and introduce himself. Just before I start, I want to make sure that everybody knows that you can ask questions at any time during the session. Just type your questions in the Q&A box and we will answer it. Keep in mind the answered questions are going to show on the answer tab. Also, time permitting, we're going to answer questions live if possible also. So I'm going to let Rohit say hi and introduce himself, and we're going to start. Rohit, go ahead.
Thanks, Sean. Hello, everyone. This is Rohit. Excited to talk about lateral movement and our application domain routing feature and capabilities. So looking forward to it. Thanks, Sean.
Sure. Thank you. Now, in today's webinar, we will gonna start with the introduction to Cloud Connexa, as some of you may not be familiar with the product. Also, I just want to mention here that we won't be using any type of sophisticated or snazzy marketing presentation. This introduction is just to reinforce some of the concepts and key terms that we will be using during the webinar, so it's going to be easy to follow along as we proceed through the session. After I'm done with the introduction, then I'll pass it to Rohit, and he will be explaining the application domain-based routing and how to eliminate lateral movements. And then I'll come back after Rohit is done, and I do a demo of the application domain-based routing and how to cloak applications, and we talk about device enforcement or identity verification and enforcement as well. So without any further ado, let's go ahead and start. I'm going to talk about Cloud Connexa. Some of you might be using the product right now, familiar, some may not. So what is Cloud Connexa? You can think of Cloud Connexa as a cloud delivered service that creates a virtual private overlay network that you can use to connect your devices and resources together securely all over the world. Now, these resources can be users, can be applications, can be private networks, or even IoT devices. So we have 30 worldwide locations or points of presence from which you can connect to Cloud Connexa and use these services. We also have integrated security features into the service, so that provides advanced security functions as well as advanced routing and secure connectivity functions. You're going to see some of these during the demo. Now, these 30 plus locations or point of presence or POPs are called regions in Cloud Connexa, and you can think of them as data centers where hosts are kernel optimized high performance servers. These regions interconnect to each other using a full mesh technology. Now, with the full mesh connectivity, basically we ensure that there is always direct connectivity between our regions, which makes the connectivity performance very high because you reduce the latency. Also, because of the mesh connectivity, there are always redundant routes present to the number of other regions. Even one or two fails, you still have another routes available to reach to the same destinations. Now, Cloud Connexa service is a multi-tenant. What that means is that the regions, the core network we talked about that connects all the regions together, and all other elements of this platform are shared with all customers, and they're virtually isolated. So we don't spin up a dedicated service for each customer. Instead, we have from the get-go using a multi-tenant architecture, which is cost effective, and we can pass that saving to our clients. The other important aspects of being multi-tenant is that as soon as you sign up for the service, that virtual overlay network, which we call it a wide area private cloud, or WPC, is created immediately. And you're going to hear us talking about WPC or mentioning WPC a lot throughout the session. So when you sign up, you'll be asked to provide a cloud ID. So that cloud ID is a unique identifier that is used to identify the WPC that will be set up for you. Now, your cloud ID will be whatever you provide, as long as it's unique in our system. Keep in mind, you won't be able to change it later on. You can add other WPCs, but you won't be able to change it. So the format of WPC is going to be the name or cloud ID that you choose, .openvpn.com, and this is the address that you'll be using to access the administration portal. So you can do your configuration, also download clients profiles or configure files for the clients to be able to connect later on. We're going to talk about that in a second. Now, for the purpose of this webinar, I just want to make sure to simplify things, so you can simply think of CloudConnexa WPC, which is your cloud ID again that you choose, as a kind of a virtual distributed router and a powerful next generation firewall, which are out there in the cloud, and it's meant only for your use. Plus, you have a backup of 30 worldwide regions as a virtual, you can consider it as a virtual port of this router, basically. So how do we connect users, servers, networks to these ports or these regions of this virtual distributed router, which we call it WPC? We use OpenVPN protocol to create secure encrypted tunnels over the internet to those regions. Now, think of it as a virtual super long Ethernet cable that connects your devices to those ports of your cloud router that is, again, your WPC. So what's needed to create these tunnels? Basically, we need to use a client app on the devices that needs to set up the tunnel. Now, the official client app is OpenVPN Connect. It's available for Windows, Mac OS, iOS, and Androids. And for Linux, we recommend using our open source OpenVPN 3 client, which also has support for data channel offload, or DCO, a technology which further improves the data throughput performance. You can also use OpenVPN protocol compatible routers like Teltonica and firmware like OpenWRT. So we call the same client application sometimes a client, sometimes a connector, and you may be wondering why. We use the term connector to distinguish the connection from a typical on-demand client connection. Even though it is the same client app, the context in which it is set up in the administration portal and the configuration profile allows the connector to create an always-on, unattended connection. And it is used basically to provide access to applications which are hosted on servers that it runs on the networks connected to the WPC. So to summarize, connectors make networks and applications part of the WPC, and clients are to connect to WPC to use services made available via connectors. Users, devices, user groups, and all regular relatable terms I'm not really going to cover here, pretty self-explanatory, but I'm going to talk briefly about host networks and applications. Basically, the host networks and applications are a representation of an application server, a private network, and any TCP/IP service in CloudConnexa. So an application server on which the connector is installed with the intention of providing access to the application that are being served is configured as a host in CloudConnexa. Whereas a private network, which provides access to the WPC for the devices on the network and can also provide access to others for applications hosted on that network or site, is represented as a network entity in CloudConnexa. Again, when I log into the portal, you're going to see options to create hosts. You're going to see options for networks. Now, Applications, when we talk about applications basically are services that are identified by a domain name that are made accessible to the WPC. For example, as you see on the screen, the host is making two services accessible to the WPC. One is FTP, and which is named as ftp.test.local, and the other one is RDP, rdp.test.local. So these are configured as applications within the Cloud Connexa, and these applications can be further guarded by providing access to only specific protocols, ports, and can later on be used with the access controls to control basically who or what can have access to those applications. So this was a brief introduction about Cloud Connexa. Hopefully this intro has given you a good basic understanding of the services and the terminology, especially since we're going to use it through this session. So here's what makes our service unique. Our service is targeted for small, medium businesses. Normally, these businesses don't have the networking and cybersecurity resources that bigger enterprises have, and sometimes is needed to manage complex solutions that they may have. So we've taken a particular attention to make our service very easy to use and configure. Again, you're going to see it in the portal. Everything is going to happen there. The other point that I want to make here is that our service comes with 3 free connections. So we do this because we want you to get started quickly and to see the benefits and the value in our product right away before making any purchases. And then once you're ready to move up and have more connections, then you can purchase connections. Now, keep in mind, Cloud Connexa eliminates the complexity of configuring routing using IP addresses instead of domain names are being used to identify applications and networks for routing among multiple connected networks. So you can have networks all over the places. You can have in the clouds, you can have in on-prem, and you can have remote users all over the places. Cloud Connexa, it does have built-in content filtering and IDS and IPS, intrusion detection system and intrusion prevention system security features. Basically provides a one-stop solution and reduce operational cost. And the last thing that I want to mention here is the economic pay as you use pricing for simultaneous connections rather than paying per users or per devices. You can have set up 20 users, 20 devices in the your WPC, but as long as the number of simultaneous connections matches with your subscription, then you're good to go. So if you have 3 free connections, but you have 20 users and 20 devices, as long as 3 of them connect at the same time, you don't really need to purchase more licenses or subscriptions. So basically, this is, again, another cost-saving aspects of this product. Okay, this was a quick introduction. As I said, this is the part that I'm gonna pass it to Rohit so he can talk about the application domain-based routing. Rohit? Rohit, if you're muted, if you're talking.
Can you all see my screen? Sean, can you see my screen?
Yeah, I can see your screen now. I can hear you. Yes.
All right, great. Thanks. So thanks for that intro on our service, our differentiators, and terms, Sean. So I'm just going to kind of discuss the main points of this webinar, and then we will proceed to actually seeing it and work. Sean will go ahead and show the demo. So before we start talking about application domain-based routing, let's kind of understand what me and rather the industry mean about lateral movement. So what is lateral movement? When we hear the term lateral, we know that it's something that's going from side to side. So basically, lateral movement is a technique used by attackers once they gain entry into a device that's on a network, they try and attack more devices or try and get access to services and data that they are not authorized by moving from one system that is connected to the network to another. And on the right-hand side, you see some examples of techniques that these attackers use. And if you search on Google or ask ChatGPT, it will come up with many of them. So some of the common ones are called pass the hash, which you use a special tool to extract the hash of a password that's stored in memory and try to get access to systems in that fashion. Another one is you try and exploit some vulnerabilities in anything that allows you remote access, such as RDP, secure shell, and try to propagate your attack throughout the network. So as you can see from some of the stats here from Microsoft and from Verizon, lateral movement is really growing and is being the root cause for a lot of data breaches. And an interesting statistic here from CrowdStrike is that once an intruder gets access to your to a network, to a system in a network, on average, it takes that intruder about 2 hours to start moving laterally into other systems on the network. So we are now going to talk about how can we prevent such kind of lateral movement and avoid data breaches, which on average cost about 2.2 million, according to this study by Ponemon Institute. So let's take a look at this illustration here. So let me use my laser pointer. So here, as you can see, we have our Cloud Connexa WPC, and we have private networks here, 2 private networks, which are using connectors denoted by this filled in circle, and are connected to our WPC. Now, these private networks, 192.168/16 and 172.16/12. These are the private networks on which the private applications reside that we need our remote users to get access to. So going down below the cloud, you see the user's laptop. The user has installed our Connect client and is connected to Cloud Connexa. Now, as soon as this tunnel has been set up, Cloud Connexa pushes to the device routes that need to use this tunnel. So in order for the traffic from the user's laptop to get to the private networks, Cloud Connexa will need to push routes to 192.168/16 and the other private networks subnet IP address to the user's device. Now, as soon as that is done, the user you are basically disclosing the private IP address subnets for your private networks to the user. So if the user is has bad intentions, the user now knows, okay, all these private IP addresses are in this range. Let me try and find out what are the servers I can get access to. Let me snoop around, etc. So, but of course, to prevent that, you can have access controls, right? So you can set up access controls, and we do have access controls even for IP services. And for IP services, the way our access controls work is we, again, for ZTNA reasons, we just push routes that the user is authorized to get access to. But there is a limit in terms of how many micro segmentations you can do with your IP address ranges. And the more of these subnets routes that you push to the device, the more complicated routing becomes within the device. And sometimes you might hit the limit for the number of routes that a device can maintain, especially for devices such as smartphones. They cannot have a super big routing table in their OS. So the other negative about using IP addresses for routing is now when you want to add another network, that network has the same IP address subnet as a network that's already connected. So there's a problem here, because now when the user is trying to get access to, let's say, 192.168.1.1, as the packet comes into the WPC is going to look up at its normal, IP-based routing table and figure out what's the next hop for 192.168.1.1. And it's going to say, oh, I know, this is the connector, and this is the network that I need to send the packet to, because the route provided to me for this whole subnet belongs to this connector. So if you try, configuring another network with the same IP address range, Cloud Connexa is not going to allow that, because if that is done, then Cloud Connexa does not know what is the actual next hop. Is it this network, or is it this other network? So basically, if you use IP address subnets as routes, you are unable to add another network with overlapping IP address ranges. So now let's look at how application domain-based routing solves this problem. So in this figure, you see that all the three networks are connected to Cloud Connexa. And you see that, this network here and this network on the right, they both have the same IP address ranges. But that is okay, because we are doing routing based on application domain names. So as far as Cloud Connexa is concerned here, it disregards these IP address ranges and looks at which applications have been configured and are being hosted in these networks that has been connected to it. So as long as the name given to applications within a network are different from another network sharing the same IP space, Cloud Connexa is good to go, because it sees here that, okay, all the applications with store1.local are in this network, and all applications with store2.local are in this network. So instead of using the IP subnets as the next hop and to determine routing, Cloud Connexa starts using application domain names. And as you can see here, you can even have public applications configured as, public domain names configured as applications. So let's go in detail and see how this works from the user's perspective. Now, when routing has been set up like this, no IP address routes are used, all the networks connected are using applications and application domain name. Then when the user connects, there is no need to send the IP address subnets. In fact, CloudConnexa does not even know what the IP address subnets of these private networks are because it's not been configured. So right away, your private IP addresses are not disclosed. Instead, what CloudConnexa sends is a big subnet IP address block in the millions, 100.80/12. And the reason it sends this is because we need to route packets to CloudConnexa using this tunnel. So this tunnel needs to be assigned to some IP address range. So that's the IP address range that is used. Now, how do we, in fact, get that routing done? So for example, let's say that the user is trying to access, file server.store1.local. As soon as the DNS query is made to CloudConnexa, CloudConnexa will create a binding and provide an intermediary IP address from the 100.80/12 subnet range. So instead of giving the correct destination IP address, the private IP address assigned to that file server.store1.local, CloudConnexa sends an IP address from this range. Now, as soon as the DNS resolution comes with an IP address in the 100.80, the destination traffic starts with that IP address. The OS in the laptop knows that, okay, for this destination, it falls in the 100.80 range. I have to go use the tunnel. So it sends the traffic to the tunnel. CloudConnexa resolves the binding and says, okay, I put this binding in place for getting access to this connector. And once it goes to this connector, it's again, a final resolution takes place to find out the actual private IP address of the destination server, and the packet is routed to that destination IP address. So that's how application domain-based routing works. And as you can see, the advantages are that no private IP address ranges of connected networks are sent. You can connect networks with overlapping IP addresses, and access control rules also becomes much easier because you can just set them up using applications names, right? So you don't have to set them up using, many subnets, microsegments of IP address subnets on which you have hosted specific servers for specific applications. Just use the application domain name, and then you can set up these controls easily and prevent lateral movement. So now let's look at all the layers of protection that you get when using CloudConnexa. So first one is that there are no inbound tunnel connections to your private network. Your private network using the connector is making an outbound connection to one of CloudConnexa's regions. So you can basically shut your network off to the internet. All your private applications are isolated from the internet. And then Sean is going to talk about DIVE, which stands for Device Identity Verification and Enforcement. What that allows you to do is set up identity rules for your device, such that only authorized devices can connect to your WPC. So, from all the infected and compromised devices out there, you can be sure that the devices that you have authorized for access are the only ones that get access. Then on top of device identity, you have user identity. And then on top of user identity, you can skip to 7. You have got access controls set up based on the user identity and application domain names. Number 5 and 6, we have covered about not disclosing the private IP address range. When you use this intermediary IP address, it even hides the private IP address of your application server. And then lastly, when configuring your applications, you can, we call it per app firewall, but during application configuration, you can specify exactly which application protocols are allowed, so that even if there's an exploit which is unrelated to the application protocol or your application, that protocol cannot be accessed. So these are the layers of protection. And if there are no questions, which looks like there are none, I'll hand it over to Sean to demo these features.
Thanks, Rohit. Let me go ahead and share my screen, and we can continue. So we're going to do the 3-part demo today. The first part, as you can see, we're going to talk about DIVE, or device identity verification enforcement. And then we're going to look at the user experience if the device identity hasn't been provisioned in their account or it's provisioned wrong. And then we're going to talk about how the private network routes are being cloaked and nothing's being shared or pushed to the clients. And then we're going to move to the second part and the third part. Now, device identity verification and enforcement is an important security control that is basically allowing only trusted devices to connect to Cloud Connexa. Now, there are 3 options. You're going to see it in a minute: off, learn, and enforce, as Rohit explained earlier. Now, when it comes to the default setting, it's off. And in order to make any configuration changes, we need to head out to the admin user interface or admin portal of Cloud Connexa. Now, I am on admin UI here right now. We're going to expand settings and then click on users. So you can see the device identity verification and enforcement, or DIVE, here set to off. Again, that's a default settings. And if you need to change it, you need to click on the edit button on the upper right corner of the screen. Here we go. Now, if you scroll down, you're going to see the 3 settings: off, learn, and enforce. Off, obviously, everybody can connect with any type of devices. And then the second option is learn and enforce. This is where you as the administrator have the option of either provisioning a device with the device ID or without device ID. If you don't do that, first time when user connects, the device ID or UUID gets registered in Cloud Connexa under their profile. Now, keep in mind, device allowance by default is 3. So the user can connect up to 3 devices, and their UUID is going to get registered with Cloud Connexa. Now, the third one is enforce, is most restrictive one. This is where you as the admin have to provision the device in their account. Now, again, device allowance is 3, and if they need to access from 3 different devices, you as an admin have to provision all 3 devices under their account. Keep in mind the minimum client connect or OpenVPN Connect app version is mentioned here, so we need to make sure all Connect apps are up to date. As you can see, I have one device that is not provisioned, and gives me an alert here that if I choose enforce, one of my users may not be able to connect unless if I go and update or provision a device. So I'm going to confirm that. Now, as you can see, my DIVE is set to enforce. Now we're going to look at the user experience. What happens if a user tried to connect from an authorized device? Let's look at one of the accounts. I'm going to go to users here, and let's pick Aiden, for example. As you can see, Aiden device is provisioned here with a UUID. I'm going to connect to another machine here in a second. Give me a second. Let me bring it up. Here we go. This is another machine. So there are two ways to see the UUID of a Windows machine. If you have the Connect app installed, you can click on the menu and go to settings, and you can see the UUID here. Another way of doing it is through the command prompt. There is a command that you can type in and get the UUID. Here we go. And as you can see, let me hit enter. As you can see, it's the same number. So this is not the same UUID that it was provisioned under Aiden's account. So let's go ahead and try to connect with Aiden's account from this machine. Again, this UUID wasn't provisioned. And let me type his username and then the password and sign in. And here we go. We're using an untrusted device, so Aiden is not able to log in from this device. Now, let me sign out here, and I'm going to head back to the admin user interface and try another user with the right device identity. So let's go ahead and look at the users here. And let's look at Bruce. As you can see, Bruce is the user that doesn't have any devices provisioned. So I'm going to provision one here. Let's go ahead and add, I'm going to give it a name, Bruce device. And then I'm going to paste the UUID of that machine here. And then this is basically the same UUID. Here we go. This is the one that pastes here. So Bruce can connect from this laptop basically once I'm done. Click on create, and here we go. The device is provisioned added under Bruce's account. So let's head back to that laptop again. And this time we're going to try to connect with Bruce's account. So let's go ahead and type username here and password and click and sign in. Here we go. And it's going to ask for the region. So choose Atlanta, and everything looks okay. Click on connect. And as you can see, Bruce is connected. Again, was expected because this device was provisioned under his account. So you can see the user experience when the device is device identity and verification is enforced. So a bad actor, even if it gets a hold of your username and password, won't be able to connect. Let's head back to the admin UI here. And the second part of the first part of our demo is basically we're going to look at that no private routes are being shared and nothing is being pushed to the client. So if you look at the settings here, we have an AWS setting basically. We have two servers time card and accounting setting on AWS. We got remote workers that they're connecting from all over the places. And as you can see, the subnet for our AWS is 192.168.0.0/24. And again, the time card app and the accounting app sitting on that subnet. And the subnet for the WPC or Cloud Connexa are these two subnets. So I'm going to go ahead and try to connect with one of the users, and we're going to look at a couple of things here. So let me bring up the Connect app. Jordan is one of your users. Let's go ahead and connect with Jordan's account here. Okay, he's connected. But let's go ahead and look at the logs here. Now, when I look at the logs, look here. Here we go. So there is no private route is being pushed to the client. Again, the two routes that you see, the subnets of /11 and /12, one has over 1 million IP addresses and the other one has over 2 million IP addresses. Just imagine scanning that many IP addresses. It's pretty much impossible to find anything. Now, let's go ahead and head out to second part of our demo. This is when we're going to add a route to our tunnel interface for private network. And then we're going to scan the private network, see what happens, if we can find anything or not. And then we're going to continue to the next part. So I'm on the admin UI. Let me go ahead. I'm going to use a Linux machine for this. As you can see, I have an Ubuntu here. Let me do an IP add. As you can see, my tunnel is up. Here we go. I'm connected to Cloud Connexa. Now, let's look at the route. And as you can see, there is no route for my private subnet here. These are the other routes for the Cloud Connexa. So I'm going to add a route for my private subnet to the tunnel, basically. So let me go ahead and type this here, /24 via, actually, maybe I should copy this here from here. Let me copy it and paste it, it's easier. And here, oh, I need to get rid of one of these. And here we go. So let me, yeah, we're good. Oops, we're good. So the IP, the route is been added. Here we go. And here it is. So as you can see, it's been added. Now, what happens if I scan that subnet? Let me go ahead and type. Now, this part of the demo, keep in mind it's recorded because this is taking a little bit of time. So in order to save time, I'm just playing this video for you right now. So let me type this, and then here we go. This is going to take a few minutes. So again, this part is recorded. I'm going to fast forward to it, and you're going to see the end of it. So now we're at the end of this scan. As you can see, scan all 255 IP addresses, and everything shows closed. Nothing is being shown open. So that's basically how we can check to see if anything is being pushed to the client or if the clients have access to any of the subnets. Again, this is for an insider bad actor if they try to scan our network and find out what we have. Now, we're getting to the last part or third part of the demo. That's where we're going to talk about the access groups and firewalls. So let's go ahead and look at the access groups here. Now, as you can see, I have multiple access groups here set up. For example, accounting. If I open it, you're going to see the accounting group. They have access to the accounting server through this access group. And then if I look at the marketing, for example, again, marketing people, a marketing team has access to the time card server and nothing else. So this is basically how we set up the access for different groups. Now let's go ahead and look at the users. I got Bruce accounting and David on marketing. So let's go ahead and connect with Bruce's account here for a second. And let me go ahead and type name and then password. Let me choose the region. Every time very first time when you log in, it's going to ask for region. After that, it won't. So, okay, Bruce's account is connected. So again, Bruce is part of the accounting team. So he should be able to access the accounting server, but not the time server. So I'm going to bring up another tab here. Let me go and type accounting. Fix this accounting.ovn lab.local and hit enter. And it should come up. And here we go. As expected, Bruce can access the accounting because it was part of the access group. But what happens if he tries to access the time card? Okay, this site cannot be reached again as expected because Bruce is not authorized to access the site. So let's go ahead and disconnect from Bruce, and we're going to connect with David. David is part of marketing. Here we go. So we're going to connect with David. So now the role is reversed. So David should be able to access the time card, but not the accounting. So we are connected. Let's go ahead and refresh this page right now. And time card should come up pretty quick here. And here we go. So again, expected, David can access time card, but what happens to the accounting if he tries to access accounting? And this site cannot be reached again. This was expected because this is how we set up the access groups or access policies. Let me disconnect and minimize this. We're going to head back to the admin portal. And the next thing we're going to look at the applications and their application type and firewalls, basically, and the ports. As you can see, there are application types, and for example, for time card, I got HTTPS. For this application here, I have HTTP and HTTPS open, and so on. Like this one for the branch office here, we got the SMB ports open, customized ports that we can choose. So there are ways of opening different ports or different protocols, allowing different protocols for different applications. Now let's look at this. I'm going to name this time card secure, and I'm going to just use HTTPS as a protocol for this one. This is how I want to show you the lateral movement of through the Cloud Connexa. So now I'm going to create one for time card unsecure, but let me choose the network is going to be HQ and then the domain, and then this time instead of HTTPS I'm going to choose HTTP. So I got two application services, one with the HTTPS, which is my time card secure, and then the other one is time card unsecure with HTTP. Now let's go ahead, head out to the access groups and create two different or configure two different groups. One can access the secure one and one can access unsecure. So I'm going to choose the marketing one. Marketing has access to the time card secure. That's fine. We're going to leave it as it is, so they won't be able to access time card unsecurely or through the HTTP, basically. Now I'm going to do another one. For example, I'm going to choose my let's say accounting team here, and for the accounting team we're going to give them access to the time card unsecure. Again, remember, they can only access the time card through HTTP, not HTTPS. We got our access policy as our access group set up. Let's head out to users. We're going to choose Bruce and David. David is marketing, Bruce is accounting, so two good users to use. Let me bring up the Connect app, and we're going to connect with David. So here we go. We're going to connect with David. Again, David is part of the marketing. He can access the accounting, the time card with through the HTTPS. So I'm going to type the HTTPS here, timecard.ovnlab.local, and here we go. We don't have the certificate, so let me bypass this warning. And here we go. We are connected through HTTPS. But what happens if I try to connect through the HTTP? Let's see, got local, and the site cannot be reached. Again, this is how we set up. So let's go ahead and minimize this. We're gonna disconnect from David, and we should connect with Bruce. Bruce is part of the accounting, and he has access to HTTP site of the time card, not HTTPS. So let's go ahead and bring up another browser or another tab here. And I'm going to type HTTPS timecard.ovnlab.local, and then here we go. We can access it because he has only access through the HTTP. Let me type HTTP. Oh, timecard. Here we go. And he can access it. So this is actually a good example of how you can set up different protocol for the same application and give access just for that protocol to a certain group or certain users. As somebody can have access to an FTP site of a web server, not anything else, and other people can have access to only HTTP or HTTPS, and so on. You know, there are so many different services, different applications that you can configure based on users and user groups. Now, I want to show you something else here very quickly. Let's see, the tunnel is up on my Ubuntu machine here, but let's go ahead and look at the routes. So the route's still here for the private subnet. Again, an insider bad actor has the subnet added to his route and try to scan. Look at, let's look at my AWS. As you can see, the IP address of my time card is 192.168.1.68. So I'm going to go back to my terminal here, and I'm going to scan this IP address to see what port is open. As you can see, it doesn't show any ports open. All ports shows closed. Again, that's because the connection is going through Cloud Connexa right now. So what happens if I just scan the address, the domain name? So let's go ahead and try that right now. I'm going to do this and map. So actually, let me clear the screen so we can see it. Let me go type and map, and then timecard.ovn lab. Oops, let me fix this, not local. So as you can see, it can't even resolve it. So this is how we use the pair-up firewall configuration to only allow access to certain group to permitted protocols. You can't even scan the server and find any open ports. Again, this is in case of a bad actor or inside bad actor trying to gain leverage by finding the open ports on your network. So this was a quick demo of different features that Rohit presented earlier during the webinar. I'm going to turn this back to him for closing and answer any questions you may have. Thank you very much.
All right, looks like it's my turn. I think I have just one slide to wrap up. As you can see, application domain-based routing is quite helpful in providing access just to applications without using IP address ranges for routing, cloaking the private IP network IP address ranges, allowing other networks that have overlapping IP addresses to also connect to the WPC, and along with use of application domain-based routing and access groups. As you saw Sean demonstrate, you can prevent lateral movement within your WPC and the apps that are being hosted in your networks. So with that, I would like to open it up to any questions if there are any, or we can adjourn. Are there any questions, Sean?
No, I don't see any questions here.
All right, then. Thank you all for your time. Please do us the courtesy of filling in one of the surveys which will pop up. And thank you for your attention.
Yeah,
Bye.
thank you, everyone. Thank you.